Alright. Okay, solve DE. Okay, now we want to see particular solution because this is with initial condition. Okay, procedure kita dah, hopefully everyone clear with the procedure. So yang you kena take note dalam DE ni, dalam integrating factor, step by step tu flow dia. Okay, flow dia, finding PQ, integrating factor, step 2, step 3. Okay, so you fahamkan dulu flow dia, nanti bila you dah buat latihan banyak-banyak nanti baru mungkin you akan lebih mahir. Okay, yang penting fahamkan ataupun kena pasti flow dia tu. Okay, sekarang ni kita nak apply lagi integrating factor but write our answer in particular solution. Okay, so now check this form. Is it already in dy dx plus pxy equals to qx?
Yes.
Yes or no?
No.
Not
Okay,
sure.
mana yang tak samanya?
Positif, negatif.
Okay, positif, negatif. Okay, positif, negatif tak ada masalah. Positif, negatif tak ada masalah. So, ambil je lah ni. Take out this. So, jadilah positif nanti di depannya. So, you will take out P as negative P over X plus 1. So, whenever you see minus here, untuk ni, you ambil negatif dia sekali bawa keluar sebagai P. So, kat sini nanti jadilah positif. So, kalau you tinggalkan negatif dekat sini, tu yang tak sama, nampak tak sama tu. So, what you can do is, you take this one. Okay, you take this negative, take it out as your P. So, your P now is negative 3 over X plus 1. So, automatic sini akan tukar jadi positif. Positif. Okay. So, for the Q, you will take all this. Alright, X plus 1 power 4. Okay. So, now, step 1, find integrating factor. Okay, take out negative 3. So you will have negative 3. So now integrate 1 over X plus 1. Dah buat ni, banyak kita buat dalam partial fraction. Integrate 1 over X plus 1. Negatif dah buat keluar. Dia jadi?
1x plus 1.
Okay, now we see ln. So we must simplify. But before that, we should bring negative 3 ke depan. So it become
Power 3.
so now cancel. Okay. Integrating factor. 1 over X plus 1 over 3. Why I cancel? Because there is a ln. Okay, ln. Step 2. So tadi I tulis balik Vx. Okay, then this is the what one? Okay, now step 2, multiply V with all this. So 1 over X plus 1 lah. So sebab kita tak guna sangat yang ni kan. So minus 3y X plus 1 times Vx. So kat sini dah tulis Vx lah, nanti tak nampak. So you tulis X plus 1 power 3, X plus 1 power 4. So So this one can be rewritten as v times y. So v times y is 1 over x plus 1 power 3 times y. Okay, can we cancel this line ni? Simplify, boleh tak? Jadi apa?
X plus 1.
X plus 1. Okay, so it become x plus 1. So how about step 3? Integrate both sides. Okay, integrate both sides. So you akan dapat y over x plus 1 power 3 equals to integral x plus 1 dx. Simple integral, we have x squared over 2 plus x plus c. Okay, but you cannot leave like this because we have an initial condition. We have initial condition. Okay, so now continue, find the solution in particular form. So we have y over x plus 1 power 3 equals to x squared over 2 plus x plus c. Given initial condition y02. Y02 is actually x equals 0, y equals 2. So this is our initial condition. Substitute here, you will get 2 over 1 equals to 0 plus 0 plus c. So c equals to
2.
2. So your final answer is y over x plus 1 power 3 equals to x squared over 2 plus x plus 2. So you can leave your answer like this or you can write it in y. Okay, x plus 1 power 3 times x squared over 2 plus x plus. Oh, janganlah plus c. Dah ada jawapan. Lupa. Semangat kita cari apa c tapi lupa masuk. Salah juga. Okay, so plus 2. Plus 2. Baru betul. So ni betul, yang ni pun betul. Okay, this is particular solution. Ni saya tunjuk balik tadi. Ni PQ. Ambil negatif kalau jumpa negatif. Integrating factor, simplify because of elon. Step 2. Okay. Step 3, integrate both sides.
Okay, madam.
Okay. Step 4. Oh, step 4 pula. Lastly, using initial condition, find value C. Okay. Particular solution. Okay. So now I give one more question that needs to find the particular solution. From exercise, question number 9. We need to write a particular solution because given initial condition. Okay. Dari satu contoh tadi baru satu kan. Okay, this is the DE. Find the solution. Solve this DE. So before we proceed, we check the form. Is this form follow dy dx plus pxy equals to qx?
No.
Not follow the form. So we must change this form. So what we should do? Kat mana yang paling ketara yang tak sama tu?
dy dx.
Dy dx. It must be 1. So how do we change the form?
Divide by x2.
Okay. If you want to divide this with x square, you should do to all terms. So divide everything with x square. Okay. So this one become dy dx plus 2y over x equals EX over X. So how about this one? Is it follow? Here?
Yes.
Yes.
Okay, take out P.
Per X.
2 per X. How about Q?
EX per X.
EX per X. Okay, EX per X. So now step 1, find integrating factor. P is 2 over X. Okay, bring up to integral 1 over X is ln X. Ni tadi dah ada kan? Okay, we need to simplify. What is the Vx after simplify?
X square.
X square, because we will bring 2 here. So cancel, it become X square. Okay. Step 2, multiply the original form with V. So we have, okay, Vx dy dx plus Vx times apa 2y over x equals to v. Untuk Vx lah ni kena tulis penuh. So x square times Ex over x. Okay, on the left side it become d dx of v times y. So x square times y equals to, cancel kan boleh? Ni dengan ni tinggal apa?
X EX.
X E X. Okay, this is step 2. Now we go to step 3. Okay, multiply both sides. So you will have on the left side x square y only. X square y. So this is integral of x EX. Dah discuss tadi awal-awal sekali. Awal-awal ke? Bukan awal. Second kot, number 14. Answer 14. So which method to use for this integral?
IBP.
IBP, alternative method. Okay, x EX minus EX plus C. Okay, so this is not the final answer because we have initial condition which is meaning x equals 0, y equals 2. So substitute back here. This is actually x square y equals to this. So substitute 0, you get 0. 0 minus E0 plus C. So what is C? What is E0? E0 is
1.
1. So C equals to 1. So gantikan jawapan dalam ni. So I can write my answer. X square y equals to x EX minus EX plus 1. Or you can rewrite it as y equals to x EX minus EX plus 1. Everything divided by x square. So this one accepted, this one also accepted. Okay, this is another example of particular solving DE using integration in particular solutions. Okay, sampai soalan yang terakhir yang kita bincang ni, ada apa-apa nak tanya? Okay, if no question, so now we will go to the last part of chapter 2. So basically, kalau you baca dia punya title of the topic, this is applications of DE. So bila you dengar application ni, janganlah rasa macam application yang susah. Okay, application is just a simple application. Okay, kalau baca soalan dia memang kita rasa macam susah. Sebab apa? Mostly information is not written in number. Dia akan letak dalam words. Okay, dia tak straight away give the DE. They don't straight away give the initial condition. So yang menjadi kesusahannya dalam application DE ni, we have a difficulties in take out the information, especially on the condition, initial condition. Okay, whenever we have an application equation, kebiasaannya lah, selalunya final answer must be in particular form. So for us to write particular form, we should have a initial condition. So dalam soalan tu, selalunya kita paling susah nak kenal pasti mana ayat yang menyatakan initial condition tu. Okay, dan kadang-kadang ada soalan, they don't give the DE. DE tidak diberi. Kita kena tulis sendiri berdasarkan ayat yang diberi. So yang itu yang jadi kesukaran. Okay. Tapi kalau once you dah dapat semua information, let's say after you take out all the information, you get the DE, you get the initial condition, you understand the question, flow untuk solution DE tu akan sama macam kita buat sebelum ni. Either you use separable variable ataupun integrating factor. Okay, itu perbezaan dia. Apa-apa application pun you buat, okay, dia akan apply apa yang you belajar. Cuma yang jadi susah kat sini, orang takut nak jawab soalan application, dia takut dia salah faham soalan tu ataupun dia tak boleh nak bawa keluar maklumat yang diberi. Okay, kita tengok satu contoh. Okay, example 17. Okay, Professor A start an experiment. So I highlight dulu. Start ni akan jadi keyword. Start will be one of the keyword. Okay, Prof A start experiment using bacteria with a population of 200. So ini informasi yang pertama diberi. This is the first information. But we don't know yet what is 200. Apa yang kita tahu is a population. Okay, population of bacteria. Okay, and kita pun tak pasti, is it one of the variable? Okay, kita tengok, kita baca lagi. It is found that the rate of population growth of the bacteria dy/dt given the rate, kadar. Okay, kadar dy/dt. So meaning this application involve variable y and t. How do we know? Sebab ada derivative kat sini, y and t. So kita tengoklah, ada lagi tak maklumat lain? Is given by, so dia dah bagi DE, tak ada masalah. Is given by, so the rate is given by this. So maksudnya dia beri DE. They give differential equation. Where y is the population. Population of what? Population of bacteria. So automatic kita tahu y is population bacteria. So 200 ni tadi, this 200 actually refer to y. Starting experiment. Starting experiment y equals to 200. So kalau starting experiment y is equals to 200, what we can say about time? What we can say about time? Starting bacteria ada 200. So sekarang kita guna dua variable y and t. How I know t is time? So rate memang tak lari daripada masa. Okay, kalau dt t refer to time. So based on your understanding with this statement, starting experiment y 200. So what we can say about the time? Zero. Mula. Baru nak mula ni. Apa-apa eksperimen kalau kita mula, we start with t equal 0 kalau melibatkan masa. Okay. So sebenarnya ini initial condition. Dalam kita tak sedar, ayat pertama tu dia bagi initial condition yang kita akan guna dalam soalan ni. Itu yang saya cakap tadi. Soalan ni jadi susah bila kita tak dapat nak keluarkan maklumat tu. Okay. So sekarang kita tahulah T is time. So this DE involve two variable Y and T. So this is the DE. Okay. Find expression y, where y is function of t. So actually, question 1, solve the DE. Solve the DE and you must write your DE y in term of t. Y in term of t. Okay. Second question, estimate the population. Kita tahu population refer by variable y. What is population at time 50? When t equals 50. So this is the question. First question, solve y. Second question, what is y when t equals 50? That's why we need particular solution. Kita memerlukan particular solution. Kalau tak ada particular solution, kita tak boleh jawab nombor 2. Macam mana nak dapat nilai y diberi t kalau masih ada c lagi dalam equation kita? So that's why we need to use initial condition. So now we already take out all the information in the question. So we take all this information. Okay, kita tulis. Okay, there's a typo on the final answer. Lepas ni saya akan bagi jawapan. Kita kira sama-sama jawapan yang betul. Okay, kita kira sama-sama jawapan yang betul. Okay, the DE for this experiment is 0.004y. Initial condition y equal to 100, t equal 0. Okay, question 1, find y in term of t. So meaning that we need to solve this DE. So which method to use? Separable or integrating factor? Separable or integrating factor?
Separable.
Separable. Tak boleh guna integrating factor sebab obviously tak ada tambah tolak dekat sini. So macam mana nak asingkan PQ? So we must use separable. So using separable group y and t. So you have 1 over y dy 0.004 dt. Recall back separable after we group, what we should do? After we group, what we should do?
Integrate.
Integrate both sides. Okay, on the left side, you will have natural log y. Okay, on the right side, you will have, this is constant. So, t plus c. Plus c. But to get the answer for number 1, you cannot leave your answer in plus c. You have to identify c using initial condition. So substitute here. So you will have natural log 200, 0 plus c. So c equals to natural log 200. Write it back. Natural log y equals to 0.004 t plus ln 200. But you can't write your answer like this because the question mentioned find expression for y. Find expression for y. So jawapan kena tinggalkan dalam bentuk y. So y is equals to, sambung sini, y equals to e 0.004 t plus ln 200. So tinggalkan macam ni saja. For question number 1. For question number 1. Okay. And then you go to question 2. What is y if time equals 50? So how we solve number 2?
Substitute t.
Substitute into answer number 1. So you will get y. So y equals to e 0.004 times 50 plus natural log 200. So please calculate the answer for me. So here you will get the correct answer.
244.
Okay. Can you give me the decimal places?
244.28.
0.28. Yes, you are right. Okay, 244.28. Okay, so this is the correct answer. Yang dalam buku tu dia silap calculate tu. Okay. So now, next example. Alright, so just ignore example 18. So we will not discuss this and just ignore that. Okay, it's not out of the topic, but ada some element dalam soalan tu need you to apply limit. So I think just ignore that one. We need to recall back the limit. So maybe kita cancelkan je lah example 18 tu. So tak perlu, just focus on example yang lain untuk difahamkan, tengok example untuk application ni. Okay, boleh baca. Okay, tapi saya just skip lah, saya tak nak discuss. Okay. Nanti lagi pening. Dah lah chapter ni pening kan. So kalau kita bagi yang terlalu out of the box, okay, nanti takut you lagi confused. Okay, this is example 19. So I nak discuss example 19. So this example lebih straightforward lah daripada example 18 tu. Okay. So example 19, a bullet is fired into a pool of sand with a velocity of 400 cm per second when it enter the sand. So let's say this is a pool of sand. Okay. So there's a bullet coming daripada atas ke daripada mana ke tak kisahlah, tapi daripada luar lah. So now it enter the sand here. Okay, once we enter kat sini, once it enter, starting je dia enter, velocity berubah ataupun start dengan 400 cm per second. Okay, so now ini je maklumat yang kita ada setakat ni. Determine the time needed for the bullet to stop. Bullet to stop. Okay. So logic, bila bullet dah masuk dalam ni, dia tak akan selamanya akan gerak. At some point, dia akan stop. Okay, dia masuk. Okay, dan dia stop. Okay, determine time. So sekarang wujud lagi satu variable. So here it involve V and time. Velocity and time. Okay, so now macam tadi juga. 400 ni mesti kena mengena dengan initial condition. V is equals to 400. What do you think about the time? Apa yang kita masukkan? When it enter, velocity is 400. So, what we can say about the time? Ni lebih kurang sama macam kita mula eksperimen. So, T equals to?
0.
0. So by the time it enter, velocity now is 400. So lepas ni velocity akan berubah. Sebab apa? By logic, dia akan jadi lebih laju atau dia jadi lebih perlahan?
Perlahan.
It will become slower. So dia akan berubah lah, dia tak jadi 400 dah. Okay. Determine the time needed for the bullet to stop. So what is T? If its velocity decreases. Okay, lagi satu. Ni soalan. What is T? When the bullet stop. So stop ni, apa yang berlaku dengan V?
0.
0. V is 0. So this is the question. What is T when V equals 0? So ni initial condition. Jangan tertukar pula. This is initial condition. This is the question. Okay. This is the variable. Okay, apa yang tak ada lagi?
DVDT.
DVDT. Okay, DVDT. Okay. So, kita tak habis lagi baca tadi kan? Tengok yang warna biru. Velocity decreases at the rate. So we now talk about rate of velocity, of course, dv over dt. So usually when we use term decreases, dv dt is negative. Kalau dv dt dia kata decreases, rate akan jadi negative. Okay, equals to what? Equals to the square root of its velocity. Square root its velocity. Okay, so soalan ni sebenarnya walaupun dia simple, tapi dia kategori yang sukar. Okay, sebab apa? Sebab DE is not given. You should write the DE based on the statement in the question. Not every of us know how to write it. Especially kalau tak perasan perkataan decreases ni. Okay. So biasanya kalau soalan application kita jarang bagi bentuk macam ni. Kita akan bagi straightforward. Punya DE dia apa? Macam soalan tadi kan? Yang ni. Yang ni. Okay. Terus bagi. Soalan ni tak bagi. So agak susah jugalah. Tapi tak apa, jangan risau. Kalau soalan kita nak tanya application, we will give you. Kita jaranglah bagi bentuk macam ni. Okay. So now we already have all the information. DE, initial condition, variable and also the question. So kita susun cantik-cantik dia punya maklumat-maklumat ni dan kita fikir macam mana nak selesaikan. Okay, initial condition tadi kita kata velocity 400 when time equal 0. Okay. Apa lagi? Question. What is T when stop, which is velocity 0? Okay. So now think of method to use here. Separable or integrating factor? Separable or integrating factor?
Separable.
Separable. Okay. So we group V. Okay. Integrate both sides. So I change the form. So that easier for me to integrate. I put the constant negative outside. Okay, V negative half. Negative half plus 1 is half. Divide by half is 2. So V power half equals negative T plus C. Okay. Substitute initial condition here. 2 times square root 400 equals 0 plus C. C equals to 2 times 20, 40. Square root 400 is 20. 20 times 2 is 40. Okay, write back the full solution. So 2 square root V equals negative T plus 40. So we can use this to answer the question. What is T when V is 0? So now substitute 0 into V. Negative T plus 40. 0, negative T plus 40. So T equals to 40. So the unit in second. 40 seconds. So this is the complete solution for the example. Okay. So for example 20, I will not discuss this in class because it's a long step. Okay, but I already put all the complete solution here because it's not given in the module. So here are the complete solution. Okay, some notes here. This is notes. Okay, recall about displacement, velocity, and also acceleration. Okay, so here I show the complete solution. Don't worry, after this class, I will share with you this slide, so you don't have to copy. Okay, I will share this slide with you after the class. Okay. So everything is written here completely. Okay. So last question for today. One question from exercise 2.4. Okay. Application question, but this application is application on graph. Okay, application on graph. We actually can apply DE in graph. Okay, so let's read the question. All right. The gradient at any point xy of a curve is 2 plus y tangent x. So let's look at this statement. What does it mean by this? Or what you understand about this statement? The first line. Gradient at any point xy of a curve is 2 plus y tangent x. Or I can add some information here. This is actually talk about gradient of tangent. Gradient of tangent.
dy dx is
Yeah.
equal to
Yes, alright. Okay, dy dx equals to this one, right?
Yes.
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 Okay. dy dx equals to 2 plus y tangent x. Actually, you learned this last semester in derivative definition, where the gradient of tangent at any curve, at any point on curve, it is actually a derivative, dy dx. So this is actually 2 plus y tangent x. Okay, that is the first information. And the curve, ni information lain pula. And the curve passes through point. So please take note. Please take note. This is not the point on tangent. Ni bukan point dekat tangent yang kita cerita tadi. Tangent can be at any point, anywhere. But this is specifically, dia kata, the graph that we talk about passing through this point. The graph passing through this point. So what do you think about this statement? Dia nak bagi tahu maklumat pasal apa ni?
Initial condition.
Yes, initial condition where x equals pi over 4, y equals 3. Ni koordinat. Koordinat. X equals to pi over 4, y equals 3. Okay. Now yang merah ni soalan. Find equation of the curve. So biasa equation of the curve kita akan tulis dalam bentuk y equals to fx. So in another word, you must solve this DE and write your answer in term of this. Y equals to fx. Y in term of x. Y in term of x. So kena tinggalkan jawapan dalam bentuk y equals to x. Okay, equals in term of x. So yang ni jawapan mesti particular. Mesti particular because the initial condition is given here. The initial condition is given. Okay, semua maklumat dah ada dah. Okay, apa lagi maklumat dia bagi? Initial condition. Okay, so soalan cari solution. Find y. Okay. So DE, initial condition, question. So now think of method to apply here. Separable or integrating?
Integrating.
Integrating. Yes, you are right because you see a plus here. Okay. And is this form follow the required form?
No.
No. So which part to change or to move?
Y tan X
What we should do with this y times x?
to dy dx.
Move together with dy dx. Yes, great. Okay. So don't worry if your q is not in term of x. Kalau tak ada x pun, jangan macam, salah ke ni? Bukan. So remember, your function can be constant. So your function can be constant. Tak kisah, tak ada masalah. Okay. So now take out p. What is your p? Remember, if you have negative, what we should do?
Negative tangent x.
Yes, correct. This is your p. So negative tangent x. How about q?
2.
2. Okay, so now we can start doing step 1. Okay. Integrate negative tangent x dx. So I bring this negative outside. So tadi ada contoh ni kan? Dah ada dah contoh integral tangent x. So kalau kita recall balik, answer for this is negative ln cos x. So because of negative times negative, so it become e ln cos x. Jawapan untuk integral tangent negative ln. But then kat sini ada negative. So you darabkan negative, it become positive. So what is the final form of v?
Cos X.
Only cos x. Okay, so this is cos x. This is v equals to cos x. Step 2. Okay, multiply each of the term with cos x. Okay. 2 times cos x. So tak boleh nak simplify, biarkan je. Cos x times y. Boleh integrate lagi. Baru step 2 kan. Okay. So this is 2 cos x. Just copy back the form. Tak boleh nak permudahkan. Okay, step 3. Integrate both sides. So you akan dapat y times cos x. Saya bawa ke depan y tu. Okay. Integrate cos x dx. What is the integration of cos x? Positive sign or negative sign?
Positive sign.
Positive sign plus c. Okay, so this is the form. Okay. So now before you write y in term of x, so I think better for us to solve for c. Cari nilai c dulu. Okay, solve for c. Okay, the initial condition is so given x equals to pi over 4, y equals to 3. So what else? So the answer just now we have y cos x equals to 2 sin x plus c. Okay, substitute. Y is equals to 3 times cos pi over 4. Okay, now I let you to calculate. So 2 times sin pi over 4 plus c. So calculate this, cos pi over 4, sin of pi over 4. If possible, give me the exact value. For those using calculator, the latest version, okay, you can give the answer in cert form. So I want the value in cert form. So siapa yang tak boleh bagi cert form, you can write your answer in decimal. No problem. Okay, so but now I want you to share with me the exact value. Siapa yang ada calculator, boleh bagi exact value, please share with me. And be careful in your calculator. If this is pi, you must change the radian, the mod into radian. If not, you should press cos 45. You should press cos 45. Kalau you nak press pi over 4, make sure you change the mod into radian. Okay. What is cos pi over 4? Cos 45 degree. Cos pi over 4. Berapa?
Square root 2 over 2.
Square root 2 over 2 or 1 over square root 2? Okay, square root 2 over 2 is same as 1 over square root 2. Okay. What is sin pi over 4?
Square root 2 over 2 juga.
Square root 2 over 2, which is 1 over square root 2. Okay, so kalau siapa-siapa yang ni I selalu share lah sebab ramai pelajar yang mesti tanya. Saya dapat jawapan lain, saya dapat square root 2 over 2. Kenapa jawapan dia 1 over square root 2? Sebenarnya ni sama. Okay, macam mana sebenarnya 1 over square root 2 is equal to square root 2 over 2. So dia ubah bentuk sebenarnya. Apa yang berlaku? Yang ni dia darab dengan atas bawah. So this is equals to, okay, square root 2 times square root 2 is 2. So kenapa kalkulator bagi jawapan dalam bentuk ni, you kena faham, biasanya komputer ataupun kalkulator, they always try to avoid putting cert on the denominator. So kalau ada cert denominator, dia akan simplify bentuk cert tu, dia akan simplify bentuk term tu supaya cert duduk di atas. So kalau you perasan you guna software mana-mana, jawapan akhir nanti dia jarang akan letak square root dekat bawah sebab dia kan dah diprogramkan. So mana-mana cert yang ada kat bawah dia akan simplify duduk kat atas. Tapi sebenarnya benda yang sama. 1 over square root 2 is equals to square root 2 over 2. Okay, so jangan terkejut pula. Okay, now please give the answer, the value of C.
One over square
C
root
equals to? Yeah, 1 over square root 2. Okay, so you can write the answer. Y equals to, Y cos X equals to 2 sin X plus 1 over square root 2. But remember, the question wants us to write Y in terms of X. So make sure that you simplify. So Y equals to 2 sin X plus 1 over square root 2. Everything divided by cos X. So you can leave your answer like this or simplify lagi. Sin over cos. Sin over cos is tangent. So 2 tangent X. Okay, 1 over cos is secant. Okay, 1 over square root 2 secant X. So both answer accepted. Okay. So with this, we are done for today and this is the end of chapter 2. Okay, before I end, any question that you want to ask related with today's topic, integrating factor and application? If no questions, so I'll end the class just until here. So we'll see again next week with new chapter, chapter 8. Okay. So there's no lecture for chapter 3. You will do chapter 3 among your group members, SCL, Student Centered Learning. So I already gave the task. So just take note on the due date. Make sure that you submit before the due date. Okay, but for next week, we'll jump into chapter 8. Why we do the last chapter? Because we are going to use chapter 8 for your mini project. Nanti kemudian I akan bagi task for mini project. Okay, so you kena apply chapter 8 untuk mini project tu. So that's why we jump into chapter 8 first. Lepas tu baru kita masuk balik chapter 4. Okay, so I rasa I dah brief you awal-awal semester dulu. So siapa yang tak perasan boleh tengok balik assessment saya yang saya bagi awal-awal semester. Okay, so thank you everyone. Take care and stay safe. Assalamualaikum.